En inglés, ¿no?
En inglés, okay. No problem.
Okay. Hi everyone, my name is Carlos León. I work in the Natural Interaction based on Language Research Group, which is led by Pablo Gervás. My talk, I'm sorry about that. Anyway, my talk is going to be about a particular instance of one of the systems we are working on. Instead of giving you a broad talk about creativity and our research activities, that's what Pablo talked about a few weeks ago, I think. I'm to be focused on one single system. This is the system I've been working in for the last 5 years. Basically, this talk is going to talk about one main problem, which is creativity and artificial intelligence. That's a big problem by itself, and a partial solution we're trying to offer. So, this is the outline. First, this too long didn't read abstract version of what I'm going to say. Then I'm going to divide the talk in two parts. First, I'm going to describe the problem, creativity and intelligence. And then I'm going to propose a solution. Of course, after that, future work, open questions. As you can imagine, we haven't solved everything. And some information. Okay, these 3 points are what I think describe the problem well. Real AI needs to be creative. Of course, this is an opinion. This is not an overall definition of what artificial intelligence should be. But to me, in order to build a machine that is really intelligent, and when I say intelligent, I mean it mimics human behavior, it must be creative. What I'm trying to say here is that creativity is not only a part of intelligence, it's partially what defines intelligence. Working on this problem, I discovered that that the way in which we think is not logical. Logics and language are an emergent behavior of our way of processing concepts. But basically, what we do as humans, when we think, we have an eventful representation of the world. We tell stories. We think in terms of narratives. And my solution is this. I propose a rich simulation-based model of a domain, of any description of what we think, what we know, and what we can process. The thing is that computers are very good at that. We know how to perform simulations. We know how to run them. And if we use that simulations as a base, as the knowledge we're managing, my hypothesis is that we can be much more intelligent and much more creative. So let's get started. Creativity and intelligence. Does anyone here know what creativity is? Or does anyone here know what intelligence is? Probably you don't. I bet you don't have a formal definition of what these are. I don't have either. But you can easily identify that, at least in social and linguistic terms. If I say something very clever, very smart, say, oh, this guy is intelligent, or this guy is not. And if I start playing the piano and play a beautiful song, you might say that I'm very creative. But still, you don't have a definition of those. But still, let's try to define what's creativity. We don't know what it is, but we want creativity. If you want to, let's say, Terminator, you got this very badass robot who can solve very complex things and kill people and everything. We want that. Not killing people, of course, but being able to, love someone, try to protect anyone, how things are. We know that for machines to be creative and for humans to be creative as well, we need novelty. That's globally accepted. If I play something which is beautiful, but it's the Ninth Symphony of Beethoven, you say, okay, this is beautiful, but it's not your work, it's not creative, it's not novel. It has been written in the past. Quality. What's quality? It depends on the artifact. Literary quality, musical quality, artistic quality, aesthetics. Those things are quality. Design quality. Whoever designed this faculty, this building, was he creative? I don't think so. This building is horrible. It was noble, but the design is not very good. Surprise. Some claim that this is a fundamental part of creativity. If I'm able to surprise you, you will think I'm creative. Think about commercials. Commercials are all about surprising. Commercials are all about telling you something that you didn't expect to be told. But still, we don't know what novelty, quality, and surprise are. Novelty is more or less simple to define. But still, how much different is the 8th symphony from the 9th symphony? How much novel those are? Well, let's be more focused. What's intelligence? As you may know, intelligence comes from Latin, and the original word means understand. Intelligent people...
Sorry.
Yes?
Intelligence means intelligare, is establishing relationships between things.
Exactly. Establishing relation between things is, I don't know how to translate this in English. Intelligare is link, interlink, something like that, right? Interconnect, yes. So,
Well, this is the root.
yeah, this is Latin root. So, I'm not going to talk about this. There are lots of talks and writings about this. But we have this something, this was published in 2014. It's the Lovelace 2.0 test. Ada Lovelace, you might hear about her, was a lady who's dead already, who talked about intelligence. And she said that for machines to be creative, the intelligent, they should be creative. But the problem is the way in which she defined the test. It was unsolvable. She offered the formal definition of the test, and it was unsolvable. No matter what you do, that machines would never be rated as creative. So Riddell proposed this thing. Basically, this is the idea. If machines are creative, it implies intelligence. So if you have a creative machine, you can already assume that that machine is intelligent. Of course, that can be discussed, but I know. But I have assumed this for reasonable purposes, as you might imagine. This is my main point. We can identify intelligence, and I don't really care whether we can define it. I don't really care whether we agree on that or not. That's not important, because we all assume all the people in this room are intelligent, right? More or less intelligent. That's all I care about. In philosophical terms, you have heard about these Chinese room problems and everything. If I'm able to build a machine that behaves in a way that passes the general Turing test, you cannot really identify if that machine is a robot or human, or even if it doesn't pass the Turing test, but still it's helpful, it collaborates, it does what it has to do. To me, that's intelligence. That's my running definition of intelligence. Okay, it doesn't mean to be general, but it's a practical definition. Okay. Let's say we want to implement that. That's the point of artificial intelligence. Let's focus on what we do. The globally accepted hypothesis, and I believe that, is that a very important part of our intelligence happens in the brain, if not everything. And the brain is built on neurons. This bottom-up approach is very interesting, but it's very difficult to manage. Neuropsychologists are able to stimulate neurons and get behaviors and everything, but they haven't managed to build a more or less intelligent agent from neurons on. We apply the other approach, the top-down approach. We follow the cognitive psychology. We focus on what we do, language, problem solving, everything, and we go to the bottom, trying to identify what are the fundamental parts and what we can do from that. So, let's focus on ourselves. We are what defines intelligence. Our definition of intelligence is defined in terms of us, of humans, because we're very, human-centric. Even we're on the 21st century, we are very humanists. This man, Robert Schank, stated that A very important part of what we do cognitively is narratives. Not in terms of literary books or anything, not like that, but the script paradigm. That's what he called it. When you go to a restaurant, you know what's going to happen. You know the waiter is going to come to you, so what do you want to eat, and you are going to order food. You know how these things are. That's a script. And your memory is organized in terms of scripts for everything. You know how to, wash your hair, or go to school, or write a paper. That's very, very small chunks of narrative knowledge. To me, it looks plausible. That hypothesis, of course, it's just a hypothesis. To me, it looks plausible. We have history. Okay, that's an easy example. We know that history is a bunch of stories in some way, right? We have mathematical demonstrations. You have states, and you go from one state to the other. You apply rules and axioms and everything. That's a kind of a script. Your wedding. If I ask you to tell me about your wedding, you're going to tell me the story of your wedding. Oh, it was beautiful. All people were there, they came, we had fun, we drank a lot, we danced, everything. A conversation. I'm not talking about telling your conversation, but performing the conversation. When you talk to me, when we have conversations, you can describe something, but you probably describe something in terms of their properties, and you create a small script to plan these scripts. What you plan to do tonight, your academic record, everything is stored in your mind in terms of scripts. Of course, this is just part of it. Okay, this is not taking into account pattern matching, something that we do very well. It's not taking into account how we process smell, for instance. It doesn't take into account how we sing. Okay, this is not complete, but it's a very important part of our memory. To me, it's just not what Shank stated, it's just the other way around. It's not that we store our knowledge in terms of narratives. It's that narratives are the term we give to our mental structures. Of course, it's basically the same, but it's another way of putting it. We are very good at narratives since we were little child. We're very good at that. Every human culture tells stories. Every human being is able to tell what's happening. And that's why from 30,000 years ago, we were able to write stories. But it's not that we learn to write stories and then our memory emerges. Is that we use our mental scripts to describe the world. Okay, now I'm taking this hypothesis and I build a whole definition of what I call knowledge. We have this problem. We have ontologies, and in a broad sense, I'm not talking about auge. I'm talking about ontologies, logic, everything. Most of you have worked with some definition of a domain. Logics, as you know, are very good. You can reason with that, you can represent knowledge. But they have a problem. They're, since the beginning, since Aristotle, they're focused on definitions. Plato was mortal, he was a man, man's are mortal, blah, blah, blah. There's a problem with this. There's a conflict between descriptions and this hypothesis that a very important part of our memories, our mental structures are scripts. Ontologies they don't lack the possibility, but they are not very well suited to represent change. If you use, let's say, ConceptNet or WordNet or any easily accessible ontology, you will find out that all they do is to describe things. They describe dogs, they describe words, they describe feelings. But they don't say what happens when a dog bites you. They don't talk about that. And that's a very important part of what we know, because when you think of a dog, you think they eat bones, and you know what eat means. You know the implications of eating. You know what goes on after that. You know that dogs are born, they die. You know that dogs run, And running is moving, and moving is a change of state. Of course, I accept this is obvious. You can represent pretty much everything with logics. First of the logics let you, describe movement. But that's not the best tool, because they're originally designed to describe things. And, sorry, what am I doing here? Okay. No, this is not working, sorry. Okay, yeah. To me, knowledge and creativity are all about change. And representing change with logics is not easy. So, according to this, having defined the problem, I'm going to propose you a solution. And simulation is a keyword here. Why? Because when we simulate things, we have a grounded representation of the world, and that's very important. I've been working on artificial intelligence for quite a bit now, and I discovered that one of the major problems of toy AI, this toy examples where you solve a problem but the problem is not real, are due to the thing that we lack grounded knowledge. You know this classical problem with monkeys and bananas and boxes. Boxes stack up, monkeys stack up boxes and they climb to get the bananas. That doesn't happen in reality. That's not the real problem. Of course, monkeys do that very well, but we need a full definition of what we're working on to be able to get a useful solution. And that's why we simulate things. I'm going to tell you about Stella. And I subtitled this Story of Love and Hate. This is my story of love and hate. I've been working on this system for 6 years now, I think. And the system has evolved a lot. Originally, it was designed as a story generation system. It's a creativity tool. And when I say story here, I mean real stories. Romeo and Juliet, Game of Thrones. That was Stella, okay? And it worked well. It turns out that you can simulate things and things happen. That's obvious, right? It turns out, I'm going to describe the system later on, that one of the problems I had to face was knowledge. Narratology, narrative properties are there, but surprisingly, we know a lot about that. We know that what's a conflict, what's a resolution, what a character is. We know all those things. But still, the problem is not saying good things about Romeo and Juliet. The problem is that you must tell your computer that people die. And when people die, some other people grieve. And when some people grieve, they get angry and they kill other people. And all those facts, rules, or whatever you want to call it, define a whole domain. And you need, I discovered this is not surprising, I discovered that in order to produce interesting stories, you need the representation of all human knowledge. That's it. Of course, that's not doable. But it turned out that when Stella was developing, it turned into a great tool to discover creativity at large scale. In creativity, you have this problem. I was talking about novelty, quality, and surprise. Of course, you can think of many other definitions, features, aspects of creativity. But in formal terms, we know that we're talking about computational creativity. Computers, as you know, don't do what we humans do. They're machines. They're, things that obey simple rules. We like to look at the problem as a set. You want to produce a story, a painting, whatever, and you can produce a set of paintings. Imagine a set. And that set includes all possible stories in the world, all sequences of characters, for instance. Some of them are real stories, some of them you cannot read them. What you want to do in that set is to discover the subset that makes sense for stories. These things are stories, and a subset of that subset that includes really good stories. Stella was developed in such a way that you could analyze the problem. You could offer not only stories, but a real analysis of what the system did. Something like, okay, I was able to produce this set. This is the set of good stories, this is a set of really good stories, and so on. That was really interesting. But I found out that that was not still the solution. The problem was still the same. What you need to build stories is to forget about stories and to focus on knowledge, because that's a real problem. And finally, Stella evolved into a general AI system. And of course, this is not going to solve everything, I know that. But Stella, according to that hypothesis that we humans think in terms of small scripts, it turned out that you could, talk to Stella. Give me a story in which this happens. Okay, now what's going on after that? I'm going to talk about some examples of this. So, what does Stella do to be able to produce general knowledge, general narrative knowledge in this sense? Basically, Stella performs a non-deterministic simulation. You know that in a simulation, think about the physical simulation with balls and gravity and everything. And most of them, physical simulations are deterministic because we assume laws of physics to be deterministic as well. If you drop a ball, the ball will fall off to the ground, right? Okay, let's say that the simulation is not deterministic. Let's say that we humans, alien characters, can decide what to do. I can keep on talking, I can leave the room, you can leave the room as well, feel free to do so. And in that sense, from one state of a simulation, you can produce a huge number of states according to every option that characters have. That makes the simulation non-deterministic. And in that way, you build a set, that creativity set of all possible stories. But that's not enough, of course, because if I give you a partial story, a partial query about the world, and you return a partial solution, I want that solution or that answer to be what I was looking for. That's why Stella is divided in two layers. The low-level layer, which is the simulation, the non-deterministic simulation, where everything happens. Think of that as a multiverse thing. And a control layer. That control layer drives the simulation. There are two problems here. One of them is efficiency. The problem of creating the whole set of all stories is intractable, as you can imagine. There's years and years and years of computing with no solution. The second problem is that it's not really important that the problem is intractable or not, because you can stop the engine at any time. The problem is that you want the system to focus on what you're looking for. If you're going to produce a sequence of events that describe Napoleonic Wars, you want to talk about Napoleon. You don't want to talk about aliens or the 25th century. You don't want to talk about that. So that overall layer drives the simulation. I'm going to explain later on how it does that. Okay, this is just a number of examples of the non-deterministic simulation. You have decision of characters. In the model behind Stella, characters have intentions, objectives, affinities, properties, a lot of things, and they make decisions. And when they make decisions, they branch out the tree. In a real simulation, you have random events. It can be raining, someone can die, someone can have a stroke, or whatever. And you have the results of actions. When you try to do something, you can be successful, you can fail, you can do something by accident. These things and some others create a huge set of possibilities in which everything happens. For that, I created this. This is not a single value, this is actually a vector of values. I call that entropy. Let's say, okay, give me all possibilities from 1975 on. You have a multiverse. You can start a war, you can invent laser guns, you can do everything. Entropy is a measurement for likeliness. How likely is it to aliens to show up right now? That's not very likely, right? If a path of a sequence of events is generated with aliens here, that sequence will have a very high entropy. Meaning that, okay, this can happen, you can take that into account, but I'm telling you this is probably not going to happen. You can play with that. In creativity terms, this is very important because it informs you, the user, and it informs the computer itself that what it's producing, it's coherent in some sense, it follows rules of the domain, but it's quite unlikely. And there's a correlation between unlikeliness and novelty and surprise. And this is a way of measuring whether what the system is producing is really novel. Deciding whether it's good or not, talking about its quality, is a problem I haven't solved yet, of course. But at least we can measure novelty.
But this depends a lot on the context.
It-
The fact of aliens appearing in a Napoleon story is very weird, but the fact of aliens appearing in a science fiction story is very likely.
Exactly. That's exactly what it does. It examines the context, it examines the setting, the theme, and everything. Yes. So it's a number of very complex functions.
Yeah.
Not very complex functions, but a lot of very simple functions, and a complex combination of those. Exactly. That's the problem with entropy, is that even if you have a high entropy, and I haven't solved this yet, you can have still a very coherent story. Think about this. Let's say the aliens show up here. Okay. And the rest of the story is completely coherent. Okay, it's okay, aliens, we discovered aliens, which might make sense. All the planets could have intelligent beings there. They come to the Earth, and later on, everything is really, really normal. There's a problem with that in my system, is that it will detect that everything is very unlikely, because according to the systems, aliens are very unlikely. But still, it's only a peak, right? This is very normal, aliens come up. And then, it's very normal what's going on after that. That isn't solved, because the context is taken into account. But in general terms, it is a single context for all the sequence of events, which is not complete. So you're right. Okay, we have that simulation. And now, how do we drive the simulation? We need evaluation. Evaluation is something way more complicated than intelligence and creativity and everything. We don't know what evaluation means, because we can analyze the system, we can check the values for the variables and everything, but we don't really know when a sequence of events makes sense or not. We have objectives. When I say objectives, there's a number of rules you can feed the system with to have the simulation focus and actually forget about the branches that won't find a solution or an answer or sequence of events for what you're looking for. It basically reduces the search space. This is very important because in an intractable problem, all you want to do is to keep on reducing the set. It's a way of identifying what the user wants. In technical terms, it's an exhaustive search in a set. And it has a Stella has a sense of distance in the sequence of events. If I say, give me the result of a simulation in which there's a murder, it filters out every story in which there won't be any murder. By computing a distance, and a distance between two stories is very difficult to compute, because there's no such a thing in reality. What Stella does is to infer heuristically what can happen from one state on. I'm not going to talk about this. We can talk about this later because it could take hours. But this is basically one of the most effective ways of reducing the search space. which is don't look into stories that will never produce a state in which that's not true. Another way is restrictions. It might look like it's the same thing, but it's not in technical terms. When I say restrictions, is that, okay, do whatever you want to do. Look for whatever state you want to look for, but never ever accept states in which this, and this happen. This is another way. This is another perspective. The way in which the engine applies those two sets of rules is completely different. These restrictions only make the set smaller, but don't identify this very little subset, which is the interesting one. The combination of objectives and restrictions make the system way more tractable. Still, it's very complicated to reach a point in which an exhaustive search has been performed, because it could take days probably, but it's not taking years and years and years, which makes multiple sense. Curves. This is the third way of driving the simulation. Have you heard about the narrative arc? This is Aristotle said that all the stories have a narrative arc. The narrative arc is this setting conflict resolution thing, and it describes the tension. I don't know what tension means, but we all experience tension, right? When you watch a movie, you read a book. That's very classical, and I used that in the first version of Stella, but then I discovered that that arc was not useful only for literary aspects of the text, but also for overall evolution. This is real output of Stella. This is romance, this is brute emotions, this is activity and causality. It doesn't matter. This is the evolution of romance in a sequence of events in a story. This is very clear. That's why I used it here. What Stella did is to accept a set of original curves. I said, okay, Stella, give me a story in which this is the romance I want. And Stella filtered out all the stories which didn't match that curve. How do I compute romance in a story? That's just a number of heuristics. For instance, romance goes up when two people kiss. Romance goes down when two people fight. You know, there are many rules for all these things. This turned out to be very, very powerful. First of all, it filters out lots of states, which is very good. And, better than that, it helps you reach that quality subset way faster. Because you are actually giving more information to the system. You're telling the system what a meaningful sequence is. Okay? So these three things drive the simulation. And this is an example of Stella. Okay? Let me run this. Okay, this is going to take some seconds. It's actually computing a story. Hopefully. Yeah. So, what you're going to see here is Stella running. You're going to see the simulation. You can see the characters moving in the world. And there's some things here that are very important. First, it's a real simulation. Oh, there it is. This is a real simulation. Things are going on here. Stella is constantly looking for a story in which something interesting happens. This text on top of the window is just a description, a textual description of the actions that produce the next state. It It's pretty slow, by the way. This is a very exhaustive search. But you can see this character is moving around, doing things. Many of the things they are doing are not well represented. Anyway, well, you see, this lady here is moving. Right now, it's trying to find a sequence of events in which this lady marries this guy, I think, and this lady marries this guy. I said that. Okay, I say, oh, give me that story. You can see that they're talking and doing a lot of things. Characters in the story are very, very deeply modeled. They have thoughts, intentions, the representation of the world. They can lie. They can talk to each other with a very restricted language. They can take things. They can drop things. They can die. They have to eat. They have to sleep. It's a very, very complex simulation in which lots of things happen. This guy is probably going to board the ship here. Boarding a ship is something you don't usually see in an AI system because it looks like it's not important, but it actually is. Because the implication of boarding a ship are huge. You're in the sea. Ships exist. There are sailors. There's a wheel in the ship to drive the ship and everything. Oh yeah, this is crossing the sea. Okay, this can take 10 or 15 minutes, by the way. I'm not going to wait for so long. But you can see how the story, the evolution of the facts is constantly happening, and you get a textual description of that. So, when you have that, I'm going to stop this. When you have that, you can do way more things than.
But then Estela will output one single story.
No, millions of stories potentially.
Yeah, I mean, it's exploring a lot, but it will show you one.
This is only a demo. I mean, the engine is producing a lot of things. Okay. In this demo, you can only draw one. Okay. But yes.
But which one are you showing? I mean, because it's going on in real time.
Yes.
So he's discarding something and he's choosing
objectives, restrictions, and scarves. It's choosing the story, the partial story. It's a partial story actually, that is with the closest distance to my objectives. It's choosing the story with
satisfies the constraints.
not only satisfaction, because many of them satisfy the constraints, but there's a distance to the constraints.
But
the closest one.
Yeah, but it has to satisfy the constraints.
Of course.
And then also
well,
be the closest to the one that...
Actually, it doesn't have to satisfy the constraints. If there's no possible state in which the constraints are satisfied, it still chooses the most likely one.
Okay.
But there's a threshold. Okay, you can, of course, you can do lots of things. You can discard. You can say that, okay, I cannot give you an answer with that. But what it's doing right now is showing the most likely story. Actually, in technical terms, it's showing the story with less entropy.
Less?
Yes. Entropy...
From the ones that are feeding the main objective, or
exactly.
The ones that are not very...
Yes.
Why would be less entropy? But
this is a demo. There's no reason why. I just want to show reasonably...
It would be least creative also.
Yes. Yes, but there's a problem.
It has to be level.
Yes. The problem is that when you choose a story with random entropy or with high entropy, sometimes you get very weird things. Really weird things. Sometimes...
Coherent things or?
Coherent in some sense, but stories that you could not ever tell. Children die or something like that. And this demo was run in London a few weeks ago, and I decided not to show children dying. It was not politically correct, right?
But it's realistic.
It is realistic. You can have that. That's why I was telling Simon, this is just a demo. You can have that. You can tweak the system to produce, very weird stories, violent stories, peaceful stories. You can do pretty much whatever you want to do. So, this is what's really important in future work. Creativity and intelligence are not only about art or literary art or whatever, are about real life. That's what I think. this scientist is one of the most important people in computational creativity, Garen Quiggins, says that there are 3 levels of creativity. There's the everyday creativity. Everyday creativity. I'm using that right now. I didn't plan every word, I'm telling you. My brain is being creative. I'm putting words together. It's language, and it's simple for me because we speak every day, right? Then there's this medium level creativity, which is think about pop songs that hit the chart list for a couple of weeks. Good songs, nice songs. That's creativity. We call that creativity because that's not everyone does every day. You don't write songs every day, right? And that's creativity. You call that as a creative person. And there's this great creativity. It's Mozart, or Beethoven, or Newton, right? To me, not everyone accepts that, but sorry, I'm going to prevent the system from evaluation. It's not working, right? Okay. To me, in order to achieve this great creativity, the Newtonian creativity, first you have to solve the everyday creativity thing. It might sound trivial, but not many people accept that. They assume that you can train a computational system to produce great musical, compositions, and there are very good systems doing that. I don't agree. General creativity, general intelligence needs knowledge about facts, music, paintings, colors, life, everything, because we have that as humans. In that sense, I want to have Stella do more things that produce simple stories. I want Stella to accept questions. Okay? What's a question? I'm going to show an example later on. But I do not want to have Stella, give me an nice story. I want to have Stella explain Napoleonic Wars. I want Stella to answer correctly. It can do that already. But I want Stella to answer creatively. Okay, it can be creative in some sense. But the problem is when you want Stella to be creative and correct. That's not so simple. It will be correct in coherence terms because it's a very complex knowledge base and it works. But being creative with aliens and being coherent with a story that makes sense with aliens, and it's fiction, and fiction is a huge problem with that because by definition fiction is what breaks your domain. And if your domain is broken, you cannot reason anymore. How to solve that? We're working on that. And this is more important. I want Stella to make questions. You know that Picasso said that computers were pretty dumb because they were only able to produce answers and not questions. Okay. This is a question in Stella. If you remember, 10 slides ago, I proposed the objective, give me a result of simulation in which there is a murder. This is literature. This is being a detective. Because if I tell Stella, okay, give me a story in which JFK is murdered, Stella needs to find the murderer. Otherwise, the president won't ever be killed. What if Stella was able to do that? What if Stella was able to produce a story and the candidate murderers included the real murderer? This is talking to your system. What if Stella could not only be able to produce a sequence of events, an explanation for that, but also rate the explanation saying, okay, this is my most likely answer. And this one's not likely, but it makes sense also. And this is important. Let's say we go one step beyond that. What if we give Stella intentions? What if Stella can make questions that are creative? What if Stella is constantly, running and say, okay, I reached to a point in which I don't know what to do because I need information about cats. I want to do something with cats because I find out that cats can produce good explanations or good stories for something, but I don't know anything about cats. What can cats do? What if Stella says, why are there so many YouTube videos with cats? What if Stella asks sensible questions? What if Stella asks, why you humans are constantly at war? Because I have that in my domain base. Why do you do that? Because according to my rules, you shouldn't be fighting as much. That's a very good question. What if we could compare reality, what Stella knows, and Stella can query about that? Okay. This is pretty much all. Of course, there was future work. I think with your research group, there are very strong points of collaboration. Of course, you've been working with simulation at agents for years, and Stella is basically a very complex simulation system, which is very interesting. Stella has a very rich model with social behavior, complex communities, and many more things. I think there's a very, very, very strong link between those two things. Creativity is, as I said, not only about writing music. It's about giving creative solutions, answers, and finding sequences, answers that are not expected to be found. What if we as researchers can be surprised by what the computers say? Data analysis and big data. I'm starting to work on this. One of the aspects of Stella that I consider to be a problem is the huge amount of data that it was producing. It was a very, very big amount of data. With this laptop, there's 4 cores, and it's, of course, not enough. And I started working with other researcher which is working on big data. And I said, okay, this is a lot of data. You can do lots of things with this. Think about the curves. To be able to compute the values for the curves in a single sequence, I basically discard pretty much everything because the system can't handle that because it's too much. And he said, there's a lot of things here you can use. And I'm starting thinking about applying big data things to perform a deeper analysis of what the system is doing to machine learn or analyze what the agents can discover. And open questions. These questions are very philosophical, but still, I would love to hear what you think about that. Machines that are really creative. Was Mozart creative? What do you think? Was he creative? You know that Mozart's father was a very harsh guy. And he put Mozart in front of the piano when he was 3 years old or something like that. He forced Mozart, his son, to learn to play the piano. He took him to concerts. He taught him music. Who was responsible for Mozart's success? Was Mozart himself? Was it his father? Who's responsible for computers that are creative? The computer? The programmer?
No, the guy who makes the knowledge.
The guy who writes the knowledge base or whatever it is?
Well, I mean, the logic.
The logic. Oh, yes, I get your point. Yeah.
My question about your very interesting talk is about engineering, because artificial intelligence, the artificial means engineering.
Exactly.
And you can talk about ideas and philosophy, but then the engineering is there. I mean,
exactly. That was
and
I'm going to talk about.
You mentioned all the questions in AI from the very beginning that are completely unsolved because
they're unsolvable. basically.
Because intelligent machines, where are the intelligent machines?
Exactly.
Nothing. And,
Yes, yes.
so,
So, still, some claim that machines must have intention to be creative. If they produce something that they were not intended to produce, that's not really creativity. I was talking to this guy, to Tonyville, a few months ago, and my question was, what's intention? What's intention? If machines must have intention, well, okay, define intention. Any definition of intention, I will buy it. And he said,
you need to have goals.
exactly. I said, would you have goals? I said, okay. All our systems have goals. Okay, that has objectives. Oh, but and he said that's not the same. Okay, what's the difference? Intentions is when you really want to reach a higher goal. Something like you're a painter and your intention is not only to produce a beautiful painting, but to give the audience the idea or the relation of the human being with the world, blah, blah, blah. He said, that's an intention. And I said, what is the difference? Not in technical terms, but in conceptual terms, with that intention and a computable goal. What if I tell my computer, find the story in which the audience will think this? That would be really difficult to engineer, but still, is there a difference? This is an open question. Conscious machines. This is way more difficult than the other thing. I know for sure that I'm a conscious being because I can feel myself. And I believe that you're a conscious being as well, but I don't know that. Do you think your computers are conscious? Mine is not, believe me. Mine is stupid. Can we measure that? I cannot even measure your consciousness. I can only feel mine. But
no, but consciousness is the capability of reasoning about yourself, and have a representation about yourself, and be able to monitor yourself. As if you were, something outside yourself. So in machines you can do this. But
self.
You need to.
Let's call that self-reflection. You can feel in some sense, or analyze, or discover, or measure yourself. Can computers do that? In some sense, they can.
But we can know which animals are self-conscious.
When I'm talking about consciousness here, I'm talking about the cart consciousness, which is not being able to. I know I'm here because I'm something that I can feel. When my brain works, I feel it. I know what I means, but
the cart was not trusting his senses. In the moment that you don't trust your senses, of course, you cannot know if the other wants anything.
Exactly.
You don't trust.
Of course, that's a completely unsolved philosophical problem. I'm not going to go into that. It doesn't make any sense. But this consciousness thing it goes one step beyond that intention thing. Can computers have a model or whatever it is, I don't have the answer, of being something and having intentions, real intentions, because they want to be famous, for instance? Can computers want to be famous? Can computers want to be famous in the same way as we can? That's an open question.
What for?
And of course, I don't have a formal definition of consciousness.
You need to have a justification, a goal. That's
yeah. There's two things here. Your point is very good, and I agree with that. The engineering point. Computers are basically von Neumann machines. With very clever ones right now, but
distributed computing is different from von Neumann.
I mean, you have
basic.
When I'm talking about this, you have transistors and electricity and everything, right?
And you are cells. And
yes. But I'm talking about laptops, real laptops. I mean, the question about consciousness is, can you reach some degree of consciousness without neurons? Soul, if we have one? I don't know.
Not today, but maybe tomorrow.
Maybe tomorrow. That's why it's an open question. And
This is a research line.
yeah,
I mean, there are people working on this.
conscious intelligence, yes.
Yeah. Well, consciousness, not intelligence. I mean,
Yes.
first is just to try is autonomic computing. Well, was this at the beginning of the 20th century? That I mean, this was a research work to say we would like to have machines that are able to self monitoring, to self healing, to self many self. And well, there was money devoted to this, and now we have more or less the same computers.
Yes.
So you see self-repairing computers. I think this is easiest that to have a level of consciousness, and then I mean for this is just at least the level the simplest one is just to be able to ask simple question about yourself. So, how are you? Oh, yeah, I'm fine. Are you well? Or have you some difficulties with your CPU? Can you repair this that it doesn't work well? No, you cannot find this. And, can we call this consciousness at the philosophical level of comparing with human? No, but well, this could be a preliminary level of consciousness, and we don't have anything.
Well, we'll have something actually. You can have an operating system which updates itself to fix some bugs.
Academic people saying that they have systems that behave in this way, and writing beautiful papers saying, but then a prototype that you can really test and reproduce and see, nothing. And on AI, this is typical. To say, for example, Shank is a good example. He said, I'm going to produce a system, reasoning, able to reproduce, understanding natural language, and then nothing at all. Shank is an excellent example.
Sang is actually making pots of money within a company he founded. He's a
From
very clever guy. He left academia and he's rich now.
From the 70s.
Yeah, I know.
So, and there are many other people.
Yes, that's exactly.
AI is a field where many people talk, but then very few engineering results.
Let's hope, or no, I'm not one of those. This is
a challenge, not more.
it is a challenge, yeah.
This means that there are many things to do.
So, after that open questions, and your questions as well, this is very good. This is a plausible approach. I call that birds and planes. I didn't invent this. Birds and planes can't fly. Both can fly, right? And we know that planes fly in the same way as birds do. They don't do the same. The physical thing is different. They both have wings, but the use of the wings is completely different. But they use planes. Planes are pretty fast. Way faster than the fastest bird, right? Did we mimic birds? Well, this is an analogy, but it's a different thing. That's my question. What kind of creativity and intelligence are we aiming for? I don't think we will be able to build humans, synthetic humans, in the short term. I don't think we will be able to, reproduce consciousness or human intelligence or human creativity. Because that's a very difficult thing to do, because we don't really understand what's going on in our minds. But what if we don't want that? Go to a library, to any library in the world. Talk to the person behind the desk and ask her or him for a book. How much is it going to take? 10 minutes? Now, open your web browser. Go to Google. Look for the book. How much does it take? 10 milliseconds? Google and a librarian are not the same. A librarian can do things that Google can't. Google can't smile. The librarian can. But Google is very good, right? We use it every day. What if the creativity and intelligence we can get is different from what we humans do, but still is useful for us in some sense? What if we have an intelligent machine that is not able to talk to us in natural language, but is able to solve problem in a better way, or a different way, or creative in the sense of being completely different as what we do? What if we have that? Would that be useful? To me, the answer is yes. But it's, again, an open question. So, that was all. Thank you very much.
Well, some more questions. No, I have a question about engineering, about building blocks in your system.
Yes.
Because this is one of the main difficulties to develop intelligent, well,
Exactly, yeah.
let's forget about intelligent, smart systems.
Mhm.
Building blocks that for students, for researchers,
Yeah.
which facilitate the task of representing knowledge, managing knowledge or information,
Mhm.
or whatever. And then, natural language is a good example. For example, you talk about ontologies, but ontologies have syntactic representation, but semantics with rules and so on.
And all
This
those
is in the literature, or everybody says, yes, my ontologies have rules, but then you cannot find ontologies with reasoning mechanisms inside that are useful.
Exactly, yeah.
And this is a real shortcoming for people, even for believing in academic solutions like ontologies or whatever. But so.
I'm not teaching ontologies because I discovered the same problem as you do. Basically, that's the problem with ontologies, is that they promise to solve the semantic problem and they only solve the syntactic problem. That's exactly what they do. That's what I'm using simulation. Because in simulation I have, I don't know if that's semantic, but I have a whole description of what's going on every time. It's not about having the term wine or pizza or sofa. It's about...
Do you use building blocks that are reusable?
Yes, in the system, yes. It's a very complex exercise of engineering. Well,
For generating.
yeah. For instance, let's say, let me focus on something simple, explainable in 2 minutes. Water, for instance. The current definition of water is pretty simple. Not because water is simple itself, but because I have only needed a simple definition of water. And I don't have to give a brief definition of this. The world is composed by entities. That's software engineering thing. An entity can have interactions with the system. And the interactions depend on the other entities. So in order to include water in the system, I have to fill in the gaps. What kind of interaction does water have with physical entities, like bodies or balls or whatever? Okay, the interaction is this, and this. It drones, you can drink water, you can blah, 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 blah.
One question, but it depends on the amount of water.
That's what I was saying, that it's only a simple definition of water, yes. In my definition, the current definition, I don't take that into account. When I say water, I'm not referring to the water which is in a glass, but the water that is in the ground, sea or river, right?
But it's not the same as in a river.
In a desert.
No, it's not. Of course, I haven't modeled the whole reality.
Okay.
Yeah, it's a model.
I was considering maybe your characters can drink water and maybe they can drown into the sea. And maybe
yes.
the sea can have waves and make the boat sink or something like that.
Yes. So.
But you cannot sink into a glass of water.
No, that could be in that building block. That could be a restriction. It's not include it right now, but it could. For instance, the building block would just define entity water and plug it into the system. It's like, what if characters touch water? What if characters step into water? What if characters put water in boxes, glasses, everything? That's interaction. Then you have the evolution. What if you have water and don't do anything with that and wait for 2 years? Well, in my definition, nothing happens. In reality, many things could happen, but you would have to include that information in the system. So in that sense, in order to include that building block, you have to define the building block in terms of change. In terms of what happens if you have this state in the building blocks? In the building block, this happens. What is the next state of both the building block, the water in this case, and the entity that interacted with the building block? That's a case of drowning. If a man steps in water, water is going to remain the same. Nothing is going to happen to water, but the man there is going to die. Okay, that's the. I know this is not a very complete definition of that, but it's how it works. It's an engineering exercise of defining what's the kind of the interface of entities with the rest of the entities, or the rest of the system. So it's not about ontologies, because that's the problem they have.
I see this is a very difficult issue.
That's why I think simulation is good for that, because simulation is a solved problem. We can simulate things. That happens every day, all over the world.
The problem is the cost of this simulation, the engineering cost and the limitation.
Building the model for the simulation.
This is a question that I always ask to people working on simulation. In which way you just know the result of the simulation, because you are programming the simulation rule, the environment, the characters, and so on. So you know more or less what are you going to the results. Also, in fact, what is the value of the simulation is just confirm or have a confirmation of the simulation stuff that you want. This is valid for the sociologists, for the
for everything.
For whatever.
In my opinion, it's not a problem of simulation itself, but a problem of the model.
Yeah.
To what extent the model resembles reality?
Right.
That's a problem with modeling. By definition, basically, a model is a restricted description of reality, and the things that you leave out might be very important. That happened with electromagnetic descriptions. Maxwell found out that the formula we were using was not complete. There was a model, it worked similarly, but the model was not complete, and he had to improve the model. It happens with quantum mechanics. We have a model of quantum mechanics, but it doesn't work very well. It works sometimes, but the model is not complete. It's basically the same case here. How do I know that my model of water behaves in a way in which the outputs of the simulation are really useful for whatever? The running answer is, so far it works for some examples. It works for generating stories, it works for making conclusions. It doesn't work for, modeling sea behavior in real terms. It doesn't work like that. It's a very, very simple model of water. Characters, model of characters in Stellar is way more complex. You need that, because most of the things we do as humans is talk about other humans. I have emotions, for instance, characters. Are those emotions in Stella? The engineering of those emotions is the same as our emotions? Not at all. I know it's not complete. Of course it's not. I don't even know that much about emotions. But for some purposes, it works. It's a valid model for some purposes. What I would want to do is to have a full model of emotions that were just the same as our emotions. I cannot do that. I think no one can. But my approach is to apply engineering concepts to slowly become near that objective, to improve the model. The good thing about dividing simulation and model is that the simulation engine is not simple, but pretty straightforward. You get the model, you evolve the model, you get the new state. The evolution of the model is what needs to be improved. So far, it's reasonably good. But of course, it's not complete. I didn't. Stella does not anything about cats, for instance. Why? Because I didn't have the time to tell Stella what cats are. Can I do that? Yes, I can. But of course, as you can imagine, I put my effort on modeling people. Is it a restricted model of people? Yes, it is. It works for generating stories? Yes, it does. It works for. Does it work for discovering who killed John Fitzgerald Kennedy? No, it doesn't. Will it? Hopefully, that's future work.
Okay, some more questions? Yeah, I think this is a very interesting
Thank you.
talk, a very interesting debate. I think this is, thank you very much.
Thank you.
One more question.
Yeah.
How close are computers to evaluate subtext, context? For example, if I say, you're the premiere of the Avengers, I am gonna hate you right now. Can computers say if the character really hates the person he's tweeting, or from the context you can say that?
I'm not sure I quite understand your question. Can you, you mean, when you say evaluate the context, what do you mean?
If I'm tweeting someone, okay,
Tweeting someone.
you are the premiere of the Avengers 2, let's say. I envy and I hate you right now.
Yeah.
Do I really mean that I envy and I hate that person, or it's just small talk?
There are two levels of context here, according to what I understand from the question.
Or if I say, give me a story where Jesse James is riding a Mustang. Will I get a story from the 19th century, or do I get a story from the 20th century?
You will get both if you leave the system running for a couple of weeks. The thing is that as long as you feed the system with information about the 19th century and the 21st century, as long as it has that information, if it doesn't have the information, of course, it can't do anything. As long as it has that,
so it has to infer that Jesse James is a character from the 19th century. In the 19th century, they usually
Yes.
ride horses, not cars.
it will do this. The system will mix everything. We'll get Jesse James with Hulk, and Hulk with Faraday and electricity. It could mix things. It would evaluate the entropy of those two contexts, and it will know that having Spider-Man in the 19th century is very unlikely. And it will try to find a cause for that. Why is Spider-Man here? Why did he travel to the past or whatever? And it will evaluate the plausibility, the coherence, everything. So that's a context in a closed thing. If when you say context, you mean external context that is external to the system, like Twitter. Right now, it would not know anything about that. So when I say context, I mean context inside my domain. For instance, the context of Spider-Man is New York. The context of Jesse James is not New York. And it will identify, it will discover that you're breaking a rule. But there are two levels of rules. Rules that cannot be broken. Something like you just cannot fly just because you want it. And rules that can be broken. Things like Spider-Man traveling to the 19th century. Why can it be broken? Because you need that for creativity. And the rules that can be broken are the rules that are involved in a high entropy. When you break one of those rules, the entropy goes up.
But what's the difference with the man flying? Because he wants.
There was just two examples. I just making it up.
They also can be broken.
Yes, but there's an engineering restriction here. Is that when you break a rule, you must know how to break it. And you must know how to recompose the rule or ignore the rule. Some of the rules, you could do that, but the system does not allow for that. Because if you could break any rule, you wouldn't know what to do with this new set of rules. Let's say you can start flying.
But if you say that you want a story where a man
Can fly, and the domain accept that, you can have that. Yeah.
So it It's
Ex-
basically how you define the domain and the rules.
Sorry?
Basically how you define the domain and how you define the rules.
The domain includes rules. When I say domain, domain has...
I mean, how you define the rules, meaning which are breakable and which
yeah. So rules that are not breakable are just encoded in the system. That's real code, right? It's like laws of physics in the broad sense. Rules that can be broken are in a different module, if you like, and are not built in terms of code, but in terms of smaller rules. Let me explain this. A rule that can be broken is composed by a list of preconditions, a list of...
like a rule engine?
It's a rule engine, yes. It's a rule engine. No, no hace falta, no te preocupes. It's a rule engine, but the components are not full logic predicates. It's slightly restricted than that. For instance, I'm making this up. Let's say that preconditions. Man, superhero, 20th century. Post conditions. Uses web, spider webs, wears funny disguise. Okay? You can break that because the components are changeable. And the more components you change, the higher the entropy becomes. And it's restricted because if you can change any component for any rule, I will lose control because I won't be able to evaluate, to analyze what's going on. So you need to restrict. For instance, you can only change one precondition with all the precondition. If you change a precondition with another one, it has to be according to some rules that are fixed. For instance, man, if someone is a man, you can only change it by someone is a woman.
Not by someone is a cat.
Exactly. Because if you don't do that, if you change someone is a man for someone is a table, I don't know the implications. Okay? So that's why there are two levels of rules. The breakable rules right now is not very complex, and it can be very more complex because there are very good rule systems out there you can use, and you can change rules and everything. But still, it all boils down to the same problem, that you need knowledge to know how to break the rules. Some people call that the meta level. It's how to evaluate the new domain. And for that evaluation, you need a meta domain that is able to reflect on the previous domain and everything. Yeah.
One question, and I think we close that.
Yeah.
If I understand well, you type the whole context. Or no? How do you
When you say you type, you say code.
you code?
Okay. Yes.
You manually build the context of all the elements.
Yes.
Yeah.
Well, yes and no. Most of it is I write the inference rules, and
Sure.
the other rules are built from that. But yes, yeah. So it's not. I don't scrap the web or anything. Yeah.
So you don't take a story about Spider-Man and it takes the context from there.
I try that. Not the story in text, but a formalized version of the story. I use that, and the problem with that is that this is a problem with machine learning, basically. When you get the story, let's say I tell you the story of Little Red Riding Hood. What I tell, the words that come out from my mouth, are completely useless because most of the content of the story is going on in my mind and your mind. When I analyze the story, I discover that, okay, Spider-Man is born, Spider-Man blah, blah, Spider-Man, Spider-Man, Spider-Man. I discover that most of the content that was involved in that story is the relation between being born and die, the implication of being a superhero. So that's why I'm not using it right now.
And that's why, because my question was, for example, there are implications that are not in the story that are surprising for us, that are not written. For example, if in your story you are not putting any gender bias, and it's the woman who kills the man.
Yes.
I mean, this is something shocking that it's not another man who is fighting, but...
Yes, I get your point, yeah.
If you are not learning from standard sexist stories, classical sexist
Yeah.
stories, and you are not introducing a gender bias.
I know what you mean. One of the things is the domain itself, and the other level, the overall layer, which is evaluating the stories. I learn from that. I learn curves, for instance. I learn objectives. Right now, that example you gave, I think Excel is not able to process that. But some other examples it can. For instance, the curve of romance, the original curve was something like this. And that curve was learned from other stories and everything. It was not a very complex learning, by the way. Learning a curve is pretty simple. But it gives you information about what the story is like. Okay, so right now I'm not able to learn how to kill someone, because that's very complex. But I know the system can learn when to kill someone, for instance, and what are the emotional implications of that. Gender is not taken into account in this version, but for instance, the difference between killing and not killing are learned from a curve. You know what I mean? So the external learning doesn't happen in the simulation, but it does happen in the top layer, which is analyzing the simulation.
I'm not sure I get it, but
Okay.
okay.
Next